you see in labs, biotech labs, chemistry labs. They usually run tens of thousands of dollars to $100,000, and we said, hey, we could probably make one for less than $100. So the protocol for this is highly customizable. You can get it to release certain amounts of fluid or whatever. But what we're going to show you today is a protocol that matches colors. We have this working for red and blue mixtures and red and green mixtures. We're having some issues with our blue servo, so we're going to show you red and green today. So Sean, do you want to tell them how it works?
So the way this works is that we have an RGB LED attached down here. When we put our template beaker inside of whatever color we make out of red and green, there's a marker you put on in the inside. On the opposite side of the beaker, there's a photoresistor that will, so the light will shine through the beaker onto the photoresistor. So you get 3 different voltage readings for the template, and those are stored in the Arduino. Then you take that out and you put in your baseline, which is whatever it's trying to replicate. So in this case, we're just going to put in a beaker of just water. When that's put in, when you input S for start the system, it does a calculation for how much from the baseline value to the template value, how much each color was reduced. And then through scaling factors we have throughout our code, it'll calculate the number of drops of each color and ideally make the same color.
Basically, we treated this as an eigenvalue problem where number of drops is related to the reduction in transmission. So we'll show you how it works. Give me a number between 1 and 10.
9.
9. All right. Everybody said the same thing. All right. So we'll put about 9 drops.
3, 4, 5, 6, 7, 8, 9. Okay, I was off. Sorry.
And give me another number between 1 and 9.
1.
1.
But it's going to be too green then. We want something that's a little
let's do
more 4.
5. 4? Okay.
Yeah. That'll make a more interesting color. 1, 2, 3, 4.
Yeah, that was 5.
Or 5.
All right. So we'll stir this up.
What happened to the red?
Yeah, I know. So one of the things we learned doing this is a lot of green and a little bit
show
of...
everybody the color first.
Sure. So a lot of green and a little bit of red makes a really kind of cool green color. It's almost like a neon green or something. So we'll put this in. Close the door. Yeah, there's nothing shady going on there. So we'll measure the template value. We're using serial input. And you'll see this LED light up as it's taking these
Point
values.
to it so people know where.
Here's the LED right here. Okay, so our template values are stored. Now we'll put in this ordinary beaker of water. And so this beaker will be used to take our baseline measurements as well as it will mix in the colors. So it's taking the baseline measurements now. And this is how we determine our reduction in transmissions. Okay, so it says 11 drops of green, 7 drops of red, which the drops aren't as large as the drops that I put in, I guess. Okay, we'll let it mix for a little bit.
So what do you guys use to mix the...
To mix, so we're using a hot plate. It has a magnetic stir setting. So we have a little magnetic pill in the bottom of the beaker, of the replication beaker. You can kind of hear it turn. It's quiet. There we go. So it's a little darker, but pretty close, I guess. There's some tweaking that has to